Dear students, today's topic of discussion is the evaluation of the Fourier coefficients. That is, now we evaluate the coefficient A0, A1, A2, A3 up to AN, B1, B2, B3 up to Bn. We know that the function sin x and cos x are periodic with period 2 pi. That is, the function sin x and cos x are periodic from minus pi to plus pi. The period is 2 pi. Therefore, the function fx represent the infinite series by fx is equal to a naught plus n equal to 1 to infinity an cos nx plus bn sin nx is called the periodic function and has a period of 2 pi. And the value of Fourier coefficient for function this fx can be determined in the interval minus pi to plus pi or within the period 2 pi. For the evaluation of Fourier coefficient, we can make use of following orthogonality properties of sine and cosine function. Orthogonality properties means this function sin x and cos x can be evaluated by these equations. That is, integration from minus pi to plus pi sin mx cos nx dx is equal to 0 for all integral value of m and n. That is, if the m not for any value of m and n, this function is equal to 0. Other is, so this is first case. Second case is the function integration from minus pi to plus pi sin mx sin nx dx is equal to pi delta mn for m not equal to 0. It means if m equal to 0, this function sin 0 is equal to 0 हो जाएगा. इसलिए therefore m not equal to 0, this orthogonality term is valid, and where delta nm is Ronnex delta, which is unity if m equal to n and 0. Otherwise, this Ronnex delta mn is equal to unity for m equal to n, and otherwise it is equal to 0. Third case is integration of minus pi to plus pi cos mx cos nx dx is equal to pi delta mn where when m not equal to 0. That is, cos mx cos nx dx is equal to pi delta mn when m not equal to 0. Now, using these three inequalities, these orthogonality theorems equations, we can find the value of Fourier coefficient to determine a naught. That is, integrating the term fx is equal to a naught n equal to 1 to infinity cos an cos nx plus bn sin nx on both interval in minus pi to plus pi we get. That is, minus pi to plus pi fx dx is equal to a naught minus pi to plus pi dx. A naught is equal to 2 pi. Other integrals becomes 0. The other terms appearing in the Fourier series become equal to 0, or you can say vanishes. Therefore, a naught is equal to 1 upon 2 pi minus pi to plus pi fx dx. This is the value of a naught in the Fourier series. To determine an, multiplying equation 1 with cos nx and integrating over x in interval minus pi to plus pi, we have minus pi to plus pi fx cos nx dx or minus pi to plus pi an cos nx dx. This is equal to what is, by applying the above orthogonality theorem, that is minus pi to plus pi fx cos nx dx is equal to an pi. This term is equal to pi. Therefore, an is equal to 1 upon pi minus pi to plus pi fx cos nx dx. This is the value of an in the Fourier series. Now, to determine bn, multiplying equation 1 with sign nx and integrating over x within the interval minus pi to plus pi, we get minus pi to plus pi fx sin nx dx is equal to minus pi to pi bn sin nx dx. Now again using the orthogonality theorem, we have minus pi to plus pi fx sin nx dx bn pi, or this is by using the orthogonality property. Bn is equal to 1 upon pi minus pi to plus pi fx sin nx dx. Therefore, we have evaluated all the coefficients a naught, an, bn. An and bn can be find out by putting the value of n equal to 1, 2, 3 and so on. This is how we calculate the Fourier coefficient in Fourier series.